So we're going to keep analyzing quadratic functions and graphing them, but now the equations aren't going to be given to you in that beautiful y equals a times x minus h all squared plus k form. Instead, you're going to have to put it into y equals a times x minus h all squared plus k form. The way we're going to do that is complete the square. So in the previous video, not previous video, but 3.2 videos, I taught you how to complete the square to solve for the roots or zeros. We are going to use the same process, but something's very important when you're completing the square. And that is that there's a y here. We're not solving an equation, we're just putting an equation into the vertex form, which means we actually can't make it equal to 0. We can't divide everything by something. So that's why there was those two videos. So for those of you who learned it the way that it didn't matter that it was equal to 0, you'll be fine. Those of you who did, there'll just be a little bit of a change on the next question. So for this one, if I wanted to complete the square, I've got x squared plus 8x. This I want to make into my perfect square trinomial, so I'm going to put the 9 on the end. I take half the middle term, so half of 8 is 4, and I square it, and I get 16. This is my perfect square trinomial, but I'm not allowed to just add 16. I have to add 16 and subtract 16. Then I can complete the square. So I'm going to get x plus 4 all squared minus 7. Beautiful. That's it. That's completing the square. So now I've put it into the vertex form, and I can tell you that the vertex is -4, -7. I can say that the a value, right, there's a 1 here, a hidden 1, so the a value is 1, so I know that, oh, actually, I can write this all down here. Sorry, I knew I put a spot. So the vertex is -4, -7, which means that the axis of symmetry is x equals -4. Since that a value is 1, the graph is opening up, so it has a min, and the min would be -7 when x is -4. It is not stretched or shrunk because the a value is 1. So right from there, I could graph this. So maybe because I'm down here, let's do it. So my vertex is -4, -7. I'm going to go over 1, up 1, over 2, up 1, 2, 3, 4, over 3 and up 9. And then I'm going to mirror image those points. All right, now the next part of this is finding the x-intercepts, or the zeros of the function. There'd be one here and one here. Now my graph is by no means accurate, but I can definitely tell that it doesn't go through a nice point, like it doesn't go through -6 or -7. It goes somewhere in between. So to find out where those x-intercepts are, I could go back up here and I could say, okay, well, my equation is y equals x plus 4 all squared minus 7. To find the zeros, right, not roots, but zeros or x-intercepts, I would just let the y equal 0. So 0 would equal x plus 4 all squared minus 7. Since I've already put it into the completed square form, I can just go further to find the zeros. I would add 7 to each side, and then I would take the square root, and then I would subtract 4. Now this one said solve for the zeros. Sorry, I've changed these typos. They're not typos, it's just that the last textbook I used the word roots. Roots are the same word for x-intercepts or zeros, but this textbook doesn't use the word roots. It uses zeros and x-intercepts, which is kind of nice. But we want these zeros just to one decimal place. So I'm going to plug into my calculator. I'd get -4 minus root 7, and I'd have -4 plus root 7. Plugging this into my calculator, I get -4 minus root 7 is -6.6. And then the other one would be -4 plus root 7. And I get -1.4 rounded to one decimal place. So it's not that I would use those to graph necessarily, but I could go to my graph now and be like, hey, did it go through approximately -6.6? Did it go through approximately -1.4? And yeah, even though my graph is horrible, I didn't do a bad job, right? So it's a way of checking, or another thing that you can do when you're solving or graphing. All right, so now we move to the next one. So this is the one where, when you look at this, if you were finding the zeros, right? So if we were finding the zeros of this equation, we could set it equal to 0, we could divide everything by 2. But we can't do that when we're finding the vertex. And what I mean by that is, if you divide everything by -2, you're losing the a value. And so you're going to be losing part of the y value of the vertex as well. So we're going to keep that -2. So we're going to greatest common factor the -2 out of both of those terms to be left with x squared minus 2x, but we're not going to divide it out of the -2. We're just going to leave that -2 on the end. Then I'm going to find the magic number by taking half of the x term, so half of -2, and squaring it. So 1 squared is 1. And I'm going to add it and subtract it. So I've done this all in the bracket because I want this to be my perfect square trinomial. But I don't want that -1. So I'm going to take it out of the bracket by multiplying it by the -2. I call it paying the toll. So you'd be left with -2 times x squared minus 2x plus 1. And then I'd have -2 times that -1 minus 2. Now I can fully complete my square by factoring this to x minus 1 all squared, and then I've got plus 2 minus 2, which is gone. This one wouldn't be a great example because if we'd done it the other way, it would have worked because it's equal to 0 and it would have been adding 0, but just trust me that if you complete the square by getting rid of the 2 altogether, that generally it will affect your vertex. But from here, this is going to give me my vertex, it's going to give me my max or my min, it's going to give my axis of symmetry. And then to find the zeros, I would just set the equation equal to 0. So this is y equals, or f of x equals. So I would get 0 equals -2 times x minus 1 all squared. And I'm going to solve for x. So divide everything by -2. Take the square root. Now, square root of 0 is just 0. So I end up with x is equal to 1. So this is only going to have one x-intercept. And that kind of works because my vertex is an x-intercept. My vertex is 1, 0. When your vertex is on the x-axis, you only get one x-intercept, or 1, 0. My axis of symmetry is x equals 1. This graph is opening down, so it's going to be a max of 0. And it's going to be stretched, not shrunk, by a factor of 2. Let me just double check that. Yeah. Okay. So my vertex is at 1, 0. It's going to go open, down, and stretched by 2. So over 1, down 2, over 2, down 4, and that's all that'll fit. No, sorry. Don't go fast, Karen. Normally it's over 2, down 4. Instead it's over 2, down 8. That looks better. Otherwise it's going to have a funky shape. And then I just reflect it over the axis of symmetry. And there we go. That's my finished parabola. All right. Well, remember when we did 3.2 and we solved for the zeros by completing the square, and then you were taught, hey, there's a formula for that. Well, guess what? There's a formula for finding the vertex, and it is derived from completing the square. So I'm just going to show you that quick derivation, because I know for some of you that helps sort of cement things for you. Let me just find it one sec, sorry. Here we go. Okay, so look at what they did. So they took y equals ax squared plus bx plus c, and they completed the square. So they took the c and they took it out of the way just when they were completing the square. They factored out that a from the x squared and the x term, and then they took half the middle term and they squared it, and they added it to both sides, multiplied by the a. So this is another way, there's so many ways of teaching someone how to show the completing the square. So you know how we talked about adding to both sides? Well, if there is an a value, you could still add to both sides, but you have to multiply it by the a, and then this y just stays along here. But anyway, they've done this whole thing where they've eventually taken the equation and solved it back for y equals. Hugely complicated, but the nice thing is you end up with x minus h. The h value of your vertex, when completing the square with a, b's, and c's, ends up as just negative b over 2a. Awesome. Okay, a very simple formula to plug into. Some textbooks might teach you that to find the y value, you could plug into 4ac minus b squared plus 4a. I don't. What I teach is that when you get x equals negative b over 2a, you just take that number and plug it back into the equation for x and then solve for y. Keeps it simpler, right? Instead of having two formulas to remember, although they are on your formula sheet, you can just do it as a substitution. So to find the x value of the vertex, instead of completing the square, now you're always more than welcome to complete the square, okay? And you do have to complete the square, right? That is an ability that you have to have, because there will be a question on a test or a quiz that says solve for the vertex by completing the square, or solve for the x-intercepts or the solutions of the equation by completing the square, right? You will have to, but if it doesn't say you have to, you're allowed to use any method you want. So you could choose to use negative b over 2a. So what do I put in? Well, I'm going to put in negative 2 over 2 times negative 1. Negative 2 divided by negative 2 is 1. So the x value of my vertex is 1. But now I need my y value. So all I do is I say, okay, well, what is y when x is 1? I'm going to plug in x is 1. So I get negative 1 squared plus 2 times 1 plus 3. And that's going to give me negative 1 plus 2 plus 3, which is 4. So my vertex is 1, 4. Now my a value, you have to look back to the original equation, and that's your a. So the a value for this equation is negative 1. So really, if I wanted to put this into vertex form, I could actually go negative times x minus 1 all squared plus 4, right? I could put my vertex back in, and I could put my a value back in and be like, hey, there you go. And so if you are asked to solve something by completing the square, this could be a good way of checking, right? Solve for your vertex by completing the square, then solve using the formula. Did you get the same thing, right? Does your equation look the same? All right, and then keep going. So my axis of symmetry is x equals 1. Then does it have a max or a min? Well, it's opening down, so it's going to have a max, and the max is going to be at 4. It's not stretched or shrunk, but it is opening down. So I'm going to start with my vertex at 1, 4. I'm going to open down with a regular shape. So over 1, down 1, over 2, down 4, and then I can go over 3, down 9. I always do as many points as I can fit to try to keep me straight. Or I guess it probably is not straight. Keep me on the proper curve. Even then, I miss a point. Oops. So for these ones, you can't use a ruler, so do the best you can, but at least very clearly show the points that it should be going through, because that's what I would be marking. I'd be like, okay, did they draw the points accurately? All right. Last one. So this one I'm not going to get you to graph. This one I purely want you to find the vertex, the axis of symmetry, whether it's a max or min, and whether it's stretch or shrunk. So we're going to plug in the formula. So pause the video, plug in the formula. The formula is negative b over 2a. So I get negative 5 over 2 times negative 2, which gives me negative 5 over negative 4, which would just be 5/4. Now, if you're not comfortable with fractions, 5/4 is perfectly acceptable as positive 1.25, right? When your fractions can be written as a decimal that didn't need to be rounded, you're welcome to, like 1.2, 1.25. But if it was something like 5/3 and you needed 1.6 repeating, no, right? You can't write it all down. So these nice, beautiful, like ending decimals, cool. Repeating or never ending decimals, no. So then you're going to plug that in. So I'm going to plug in 5/4 because I fear no fraction, and I think the more practice we have with them, the better. So we get negative 2 times 5/4 squared plus 5 times 5/4. I might be regretting my decision a little bit. Okay, so then I would keep going. So if you want to use a calculator, if you want to use a decimal, cool. I'm going to do the full thing. Okay, so I squared 5/4. I did 5 over 1 times 5 over 4, and now I'm going to do negative 2 over 1 times 25 over 16, so that's going to simplify. 2 goes into itself once, and into 16 8 times. So I get negative 25 over 8 plus 25 over 4. I'm going to create a common denominator. Negative 25 over 8 plus 50 over 8 gives me 25 over 8. Oops, 25 over 8. Again, if you had used a calculator right from the beginning, you would do negative 2 times 1.25 squared plus 5 times 1.25, and you get 25 divided by 8, which isn't a bad decimal, right? 3.125. So totally up to you. But be careful, the back of the book might answer as fractions, and so make sure you can convert from fractions or decimals back into fractions. So this answer would be the vertex is 5/4 and 25/8. The axis of symmetry is x equals 5/4. And this would be a max, because my graph is opening down, of 25/8. And it is stretched by 2. Cool. That is the end of this video. If you're curious, what if you did want to do this one by completing the square? Some people, once you get used to completing the square, you actually kind of find it easier. So if I was to do this one, right, I'm going to take that -2 out, then I'm going to take half the middle term squared, so half of 5/2, and then I'm going to square it. So that gives me 5/4 squared, so I get that 25/4. And then I'm going to minus 25/4. The only part I want is the positive, so I get -2 times x squared minus 5/2 x plus 25/4. So this is the one where, like, if you wanted to, you don't have to put the negative in the bracket. You could put it outside the bracket. Just make sure it gets multiplied by that a value if you were looking at that vertex proof, right? And then finish it off. -2 times x minus half that middle term. And then this would be plus sorry, this was supposed to be 16. Could you hear my brain working? I was like, no, it didn't work. I was trying to do this too quick. I was like, I'm getting a different answer. So just be careful. I went right, so I went half the middle term is 5/4 and squared it, and I squared the 5 and I didn't square the 4. So this is 16. So hopefully some people aren't watching this video. Sorry for that if you are. But I get 50/16, which, so this would be 50/16, whoops, which simplifies to 25/8. So for me, I mean, especially if you're keeping with fractions, I think completing the square is actually easier. A lot of people are like, oh, vertex formula, it's so good. It's good if you're okay with decimals, but completing the square, like, that took me 3 lines. Right? Sure, I made a mistake, but that's because I was rushing, and I shouldn't have. Like, looking at this, if I had completed showing my work, right, I would have had 5/4 squared, and I wouldn't have made that mistake. But it's kind of nice. So you decide, do whatever you want. You'll never be forced to use -b/2a, because completing the square is a great way to do it. Good luck.